they're really difficult to design when you have 1 hour interview and you're crunched for time. List down all the features that you're thinking about, list down all the problem areas you can think about, and choose a subset of problems to tackle. Personally, I like to start with the most important class. In our case, it is the game board. The reason for this is because you can think of the system, the entire system interacting with this most important class, and you can build the solution slowly, keeping the whole thing extensible. If you go for the smaller classes, inevitably what you do is you detail them too much, while the important, the elephant in the room is being ignored. So a board is nothing but a 2D matrix. But a matrix of what? Had this been a complicated game like chess, I would have been defining this as a 2D matrix of squares, where square would be a complex object, and each square would be having the player who is currently playing on it, the piece which the square is occupying, whether it's under attack, so on and so forth. But because this game is tic-tac-toe and it's quite simple to design, I'm going to be taking each square as just an integer. The integer is going to be defining the state of that square, as in, is player 1 currently on it? I mean, basically, have they made an X on it? Have they made an O on it? Or is that still empty? So this is a 2D matrix of size n cross n of ints. The other thing I'd like to store on this board is who has won the board. So has player 1 won? Has player 2 won? Or is it still to be decided? Or if it's a draw. So we can have 4 states over here. This seems enough for defining the board. So let's get to the behaviors that the board will have. The first thing is we can initialize this board. That will be initializing the 2D matrix to empty squares. I'm also going to be having 2 simple getter methods so that you get the winner or get the board status at any point you want. Interestingly, over here, you also need to have the current player, as in who's going to make a move on this board. This is going to be a flag which is going to be switching between the first and second player. So if the first player plays, then the current player switches to the second player. And finally, we come to the important guy, which is make move. So whenever you make a move, you pass in a move object. This move object is defined by the player who's making the move and the cell in which they're making the move. In our case, it's going to be a row and column. It's highly likely that you'll be asked to implement the make move function, so we'll get into detail with this later on. 2 other objects which pretty much define the entire architecture is the user object. It's going to have an ID, and it's going to have the statistics related to that user. You can also build a profile on this user, but I'm just going to be focusing on the game bits. Statistics is something which is going to be a complex object. You can get into anything you like. I mean, ELO ratings can be put in over here. You can think about how many wins, how many losses, what is the best opponent you've played against, so on and so forth. So this is more feature based than anything else. Finally, we come to the game object, which is going to be tying the user to our system. The game object has an ID. It has 2 users, so we'll be needing 2 user IDs, user ID 1 and user ID 2. And we also have a list of moves that we are going to be making here. Why do we have a list of moves? Well, we can actually run through the entire game, so the user can later on maybe download this game as a text file, with the moves recorded, or you can actually implement the undo function easily by starting from the 0th move and going down to move -1, move length -1. So that's one way to implement the undo function. In our case, of course, it's extremely easy. You just look at the last move and you just revert it. So you set that square to empty. But in a game like chess or something like that, maybe making the moves is simpler than undoing the board. So in certain games where reversing a move is extremely difficult, the undo function can be implemented just by replaying the entire board. This class diagram is quite extensible, and during an interview, you can code all of this and then discuss more features if required. What I'd like to talk about now is the make move function, and specifically there's an important variation for the tic-tac-toe game. What you're being asked here is the class diagram, and you have the whole thing designed. Now, your interviewer asks you that you need to make a move in order 1 time, and you also need to tell me who the winner is in order 1 time. So imagine an n cross n tic-tac-toe board, and you need order 1 operations for make move and get winner. So this is not as trivial as it might look. If you are making a move and you just go and set the square over there to be the player who's made the move, getting a winner is going to require you to run through all the rows and the columns and the diagonals and then tell if there's a winner. So that's going to be n squared. There's a smart way to do this, sort of. Whenever you're making a move, that's the only time that a person can actually win. So whenever there's a winner on a tic-tac-toe board, the winner is decided when they're making a move, right? If you make an X, that's the only time you can actually win the game. You can't win the game when your opponent is making an O. So that's an important observation. And the place where you're making the X has to be part of the winning move. That's also an important observation. So using that, what you can do is, this is what most of the candidates get to. It's that the move I made has to be part of the winning move. Therefore, I'm going to be checking the row, the column, and the diagonals that my current move is touching. Yeah. So this is reducing the overall complexity to order n, because what you're doing is you're looking at the current row, the current diagonal, and the current column. That's the only thing you're doing. So at most 4n. Let's see how we can do that in code. All right, the first thing that we should do with a code is define a constructor. A constructor is something which takes in required parameters for initialization and then initializes the state of the object. The only state that we have over here is a 2D matrix of a board. So in this matrix, the way I'm going to be populating it is, if player 1 makes a move in that row and column, then it is set to +1. If player 2 makes a move, then it is set to -1. And the only function that I'm going to be defining here is the move function. So looking at this, you can kind of understand what is the logic behind defining the other functions. I'll be sharing the link for the code in the description below. Before you start writing your code, make sure you define your function really clearly. This is, like I said, a good precursor to API design, and this is something that people evaluate quite a bit. So the move function will be taking in a player, a row, and a column. The player is either 0 or 1, so that is either the first player or the second player. And what this will be returning is an integer value. So if it returns 0, it means that nobody has won through this move. If it returns +1, it means that player 1 has won. If it returns -1, it means that player 2 has won. Starting off with what would be exceptions. Like I mentioned, if the player is the first player and they make a move, I'm going to be populating that index with -1 on the board. Next thing I need to do is check for this row. If this row is all of the player's symbols, it means that the player won the game. So I'm going to be defining a flag, which is the win flag. And for every column in this row, check whether this player's symbol matches. If it does, then set the flag, keep the flag set to true. If it doesn't match at any given point of time, set the flag to false and break. If the win flag is set to true after the for loop, it means that there were no other coins apart from the player's coins, and this player has won. So what I'm doing over here is returning -1 or +1 depending on who the player was. We can simplify a bit over here by setting the player value at the start of the function. Now we need to repeat ourselves a few times for the column, the diagonal, and the reverse diagonal. It's only necessary to check the diagonal if you have actually made a move on the diagonal. So if the row is equal to the column, then you check over there. And similarly for the reverse diagonal, if the row is equal to the size of the board -1 minus column, then you check for the reverse diagonal. This is a well-known condition for reverse diagonals, and it's pretty nice to remember, but you don't really need to. You can even derive it on the spot. Now we're seeing that there's a lot of repetition for this program. 4 of these parts, all of them which are checking for a winning condition, are very, very similar. So after a little bit of thought, what you can see over here is that the for loop, the winning condition, setting the winning flags, and then returning the winner is all very, very similar because they are running in a for loop of size n. So although it might not be as efficient, what we can do is, for code clarity, we can pull all of these actions, which is searching on the diagonal, reverse diagonal, everything into one for loop. And that's what I'm going to do over here. I'm just pulling all of these into a single for loop, which is going to run from 0 to n. And in that, I'm going to be searching for all 4 conditions. Now, of course, you see that if I break from the for loop over here, that would be wrong. So I'm removing all the break statements. And because the 4 conditions require 4 different variables, I'm defining 4 different Boolean variables for win row, win column, win diagonal, and win reverse diagonal. So this is correct, this is fine. Maybe the contract of the move function can be a little simpler because the player which is being passed in is 0 or 1, and we are returning -1 or +1 or 0. So it seems a little odd, but if you make it a 0 or 1, then how do you tell it's a draw or not? So you could return a -1 then maybe. But I prefer this. I prefer this as an API compared to the other one. So let's keep this and move towards the challenge, which is replying in order one time who is the winning player. We have already discussed that every time you're making a move, that's the only time that you can actually win. And the only person who can win after you've made a move is you, right? Just after you've made a move, you could be the winner. That's all. This makes finding the winner in this board in order one time possible. How? Well, we can pre-compute your score for every row, column, and the diagonal and reverse diagonal. What this means is that every time you make a move, instead of us running through the entire diagonal or running through the entire row, we have those values stored. Your score is already stored for that entire row. And if your score hits n, that means that you have filled up the entire row with your own symbols, and so you should win. Right? So this is pretty simple. All we are doing is storing these values in a row array, a column array, and a reverse diagonal and a diagonal variable. So anytime this hits n for you, you win. There's another additional optimization here. Because we are storing these values as +1 and -1, all we need to do is just find the absolute value. If the absolute value ever hits n, it means that all of the symbols are same, right? Because the only time as a second player, if you're making -1s all over the place, I mean, if the entire row is yours, then it is going to be -n. Any other configuration won't give you -n. And similarly for the first player. So if the absolute value of the row or the column or the diagonal, reverse diagonal is n, then you win, right? So every time you make a move, we increment your score for that row, and we increment your score for that column, for the diagonal and the reverse diagonal if it is required. Finally, we check if any of these have an absolute value of n and return the result. Constant number of computations makes this order one time. The focus should always be on code clarity and on defining what you're trying to solve instead of trying to algorithmically solve this as quickly as possible, or naming the variables CC or DD. That's not going to help over here. Make sure that the code clarity is really nice and you are talking to an interviewer while you're doing this. Of course, tic-tac-toe is a relatively simple program to start with. Hopefully in the future, we are going to be heading for chess, which is a very complicated object-oriented programming question. Thanks again to our channel members. Their increase is the winning player. We have already discussed that every time you're making a move, that's the only time that you can actually win. And the only person who can win after you've made a move is you, right? Just after you've made a move, you could be the winner. That's all. This makes finding the winner in this board in order one time possible. How? Well, we can pre-compute your score for every row, column, and the diagonal and reverse diagonal. What this means is that every time you make a move, instead of us running through the entire diagonal or running through the entire row, we have those values stored. Your score is already stored for that entire row. And if your score hits n, that means that you have filled up the entire row with your own symbols, and so you should win. Right? So this is pretty simple. All we are doing is storing these values in a row array, a column array, and a reverse diagonal and a diagonal variable. So anytime this hits n for you, you win. There's another additional optimization here. Because we are storing these values as +1 and -1, all we need to do is just find the absolute value. If the absolute value ever hits n, it means that all of the symbols are same, right? Because the only time as a second player, if you're making -1s all over the place, I mean, if the entire row is yours, then it is going to be -n. Any other configuration won't give you -n. And similarly for the first player. So if the absolute value of the row or the column or the diagonal reverse diagonal is n, then you win, right? So every time you make a move, we increment your score for that row, and we increment your score for that column, for the diagonal and the reverse diagonal if it is required.
Find the um uh, longest palindromic substring. How do we find it? Let's go. Let's go out in JS. Yeah, we gotta find it in JS. Yeah, how do we find it? Okay. So basically check palindrome. Okay. Holy shit, no way. You were literally making this while loop out. Oh shit. Oh no, 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 no. Come on. Holy shit, no way. Let me check it out. And let's see what do we have here. Nested for loop for make mark start and end index. Okay. So I is gonna be like so n is our length. Max length is yeah, at least it's gonna be one. Okay. So what do we got here? What do we got? Yeah, we may check if substring is palindrome. Right. Yeah, indeed sounds good to me, but this is not, this doesn't look naive approach. Yeah, this is bad. Give me some good, better approach. Yep, give me the better approach. The better approach to using expansion from center. What a better approach one? Eight-bit array. What the fuck is this? New unit 8-bit. ये bit array बना रहा है. You know what? Let's solve one of the best question. Just gonna clear it out. Make space for neat code. Okay. Linked list it is. Oh no. Oh shit. I'm done. Oh shit. Actually, I tried it. Let's see if it worked. No, it did not. So the thing is that at least one should be solved. Given the head of the linked list, remove the nth node from the uh, end of the return its head. I can do one thing. एक while loop चलाता हूँ, ठीक है? Now, can you do this in one pass? That is the problem, no? One pass now. Count is gonna be 1. Count is smaller than equals to n. Okay. Smaller than n basically. Okay. If count equals to n, and नया क्रिएट हो रहा है. फक नया क्रिएट हो रहा है ये. क्या मेरे दिमाग में ये आता ही नहीं है यार. कैसे करूं मैं इसको? Like, how do I make sure that I copy the whole list? How do I copy the whole list? So I make, like, let's, okay, head. We're gonna make temp head equals to head. All right, now. यार कुछ समझ में नहीं आ रहा. Node. Okay, node goes here. Okay. So node को ये असाइन करूँ कि ये असाइन करूँ? नोड को करंट असाइन करूं या फिर alright, you know what, let's just say node dot val is equal to temp temp head dot well, comma, node next equal next put जाएगा नहीं. Yes, and show you out. Girl, I just wanna show you out. What you got? I wanna So, uh, इसमें well तो assign हो गई, but how do I assign next? चलो यार देख लेते हैं यार। एक तो ये साला लिंक लिस्ट है, आई हैव अ प्रॉब्लम विद दिस मैन। लिंक लिस्ट में कैसे मैं, क्या मतलब? I see what you're trying to do. You currently will have few issue. It's problematic. If ampere is zero, the loop won't run, even though code node exists. You should loop while itself loop while ampere itself is not null. All right, is not null. Null, maybe. All right now. I know for a few issue, a logical issue. You are incrementing count and skipping when count, but this doesn't align with the problem statement. The task is to remove nth element from the ah from the number. You need to know the total length of the pointer approach. Ah, approach. How do I find the two pointer approach? You need to know total length first, or use two pointer approach. Node constructor necessary. Okay, तो टाइम लिमिट इसमें एग्जिट हो गई। तो सबसे पहले ये वाला size equals to 0. Let's count it with every while. We're gonna do the same thing to count uh, while. Tonight I wanna show you out. What you got? I just wanna see what you got. Eh, 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 eh. I'm just fine tonight. If we count every element, if we have 5 elements and n is given 2, 5 minus 2, basically 5 minus 2 plus 1, 5 plus 2 plus 1. So we're gonna have size minus n plus. This is all we gotta do. Oh no, can we get it? टाइम लिमिट एक्सीड हो गई है भाई। ओके ओके हो गया। दीदार क्या होता है? भाई यार ये क्लाउड कोई पूछना चाहिए पैंस लोग। क्या भाई यार। somebody to love. भाई यार अपने पास टाइम नहीं है, एक जल्दी से लॉग मारना है भाई। एक्सप्लेन करो यार, ये क्या है, मैं स्टॉप करना ही भूल गया मैं, कैसे करते हैं ये। कम ऑन यू कैन हेल्प मी। मिसिंग है टेम्प हेड नेक्स्ट इज नॉट skippable gauge. Discuss an infinite loop. Okay, missing temp head. Non skip skip skipped case. What the fuck is all I know with her maybe we have. Alright. तो सबसे पहले मैंने तो साइज पता कर लिया। ओके, काउंट स्टार इंडेक्स टू स्किप। ओके, इंडेक्स टू स्किप बोलते हैं इसको। चलो चलो एज ओके आई गेट इट। So is not equals to null if okay, if count is not equals to okay, it's okay. Yeah. If you are boyfriend, never let you go. If not equals to this, हाँ ये बेटर है। आई थिंक कंटिन्यू का अपन सवाल नहीं रखते हैं। यू गोना मेक इट वेरी सिंपल बिकॉज दिस इज प्रोबेबली द रिपीटेड पार्ट, राइट? यू गोना कीप इट सिंपल, जस्ट रिमूव दिस। God damn it, what the fuck did I do? Na, 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 na. Yeah, girl. Na, 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 na. Node equals to well. Temp head dot well. Let node two, three. में जीरो कैसे आया? अरे जीरो कैसे? तो सब में ही लास्ट में जीरो आ रहा होगा फिर। एक्स्ट्रा जीरो आ रहा है यार, गिवन वन पे। हाँ, में जीरो आ रहा होगा। What do we want here? We give it your time. I just wanna create a new empty node. Okay, extra node, वही तो मैं पूछ रहा हूँ, कहाँ से ऐड हो रहा है एक्स्ट्रा नोड? Oh fuck. Oh no 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 no. अरे मैंने किया है तो मेरे को बताओ ना। और मैं तो क्या रही है My boy told me one and only. घंटा बैठ जो समझ में नहीं आ रहा. I only want this last node to be removed. Fucking fix this shit, yaar. Give me the simple solution, bhai.